So we'll continue our today's discussion. In the previous class, we have discussed about the different the functions are responsibility of the operating system. We have discussed that process management, processor management, memory management, I/O management, disk, file, all these being managed by the operating system. So today we'll be discussing about the booting process and some of the common types of operating systems. So coming to our first topic as the booting process. What do you mean by a booting? Already I told you in my previous class, booting means loading of operating system into memory. Loading of operating system into memory, the process is known as the booting. So booting doesn't mean that only start the computer. Computer may start by just by giving the power button, by switching on the power button. But booting says that operating system, the process of loading the operating system. And that program is the bootstrap program which loads it. So when you switch on or restart a computer system, the initial program which run is a bootstrap program. What is that bootstrap program? You might have marked that when you switch on the computer, you will find a light glows from the different hardware devices, from your monitor, from keyboard, from whatever the devices are connected, you will find a light glows from every device. This process, this is called the what? Post, power on self test. It tests itself whenever the power is on. Then in the ROM itself, ROM or EPROM, which is present, the BIOS chip it is there, which that is also known as the firmware, which is responsible for checking all the devices and initiate the computer so that the operating system can be loaded. There must be some instruction which must try to read the operating system. That program is the bootstrap program. It is being stored in ROM or EEPROM, electrically erasable programmable read-only memory. ROM is read-only memory. Why is it read-only memory? We cannot change it. It is there in the chip itself. On the board and the motherboard, there is a chip, ROM chip or EPROM chip, which is usually called the firmware because it is being designed by the firmware itself, the manufacturer. We cannot alter it. What is the instruction? There is a small program, bootstrap program, which is present in the EPROM, which is responsible for loading the operating system into memory. Where your operating system resides, operating system may be on your disk, hard disk, maybe your properties or CD-ROM, somewhere your operating system resides. So what the bootstrap program does, it initializes all aspects of the system. It loads the operating system kernel and starts execution. If you have remembered in the previous classes I have told, kernel is the part of operating system which always resides in the memory. So bootstrap program is responsible for bringing that kernel part into the memory and it will start execution. Once operating system starts executing the first process name is INIT. First process that is created on the machine is called the INIT. This is important. Sometimes it's called as a short note. What is the first process that is being initiated? First process name is called INIT, initialization. And its process ID is actually 1. Process ID is 1. Anyway, so it will start the INIT process first and wait for some event to occur. Is that clear? So bootstrap program which is present in EEPROM, which is responsible for loading the kernel into the memory and creates the first process, executing the first process. When an event is occurred by an interrupt from either hardware or software. Event is occurred by an interrupt from either hardware. So I told you interrupt can be a hardware interrupt or software interrupt. Last class we have discussed. So event may occur during the execution. Hardware triggers an interrupt at any time by sending a signal to the CPU. Software, similarly, software triggers an interrupt by executing a special operation that is called system call or monitor call. So either it is a hardware interrupt or a software interrupt. If it is a hardware interrupt, like I want the attention of keyboard or monitor, in that is a signal is given to the CPU. If there is a software interrupt, there is a special operation is called the system call or monitor call is there. System call, monitor call we will discuss in detail. But that in this slide, two things you have to remember. One is what is bootstrap program, what do you mean by booting, and first process is known as the INIT process. Correct? When CPU is interrupted, how CPU is interrupted? Either through the hardware interrupt or the CPU or the software interrupt. When the CPU is interrupted, what it does? It stops the current work and transfers execution to a fixed location which contains the starting address where the service routine for the interrupt is located. So do not confuse over here. Very simple. It says that CPU is currently doing some task. An interrupt occur. When an interrupt occur means CPU has to stop over there. So CPU will stop working what it's doing. So in return to the, by responding to the interrupt, it will call a service routine. A small code is already written that it will execute. How it will execute? The address, the starting address of that routine is already present. So CPU will get that address, starting address, execute the routine and comes back. That routine, small routine is called the interrupt service routine, ISR. That is called the interrupt service routine. So to handle the interrupts quickly, a table of pointers to interrupt is used. What it does now, all these addresses are being kept in a table. To handle the interrupts quickly, a table of pointers to interrupts is being used. Whatever the interrupts are there, for every interrupt, the starting pointers are being stored. The interrupt routine is called indirectly through the table. A table of pointer is stored in low memory. That this table is present in the memory itself, in the low memory. Low memory means the first 100 locations maybe. This is only, this is given the first 100 locations. In some machines, architecture may differ, but low memory is one part of the memory where the system programs resides. So there only all these interrupt addresses are being stored. The table stores the address of interrupt service routine for various devices. These array of pointers, what you have that I called, this is called the interrupt vector. This is called interrupt vector. So what it interrupt vector contains? The addresses of all these, the addresses mean of these interrupt service routine which have to be executed. So the array of pointers is known as interrupt vector indexed by unique device number. For every device there is a separate interrupt vector. After the interrupt is serviced, the safe return address is loaded into the program counter and the interrupt computation resumes. For example, you have written a program at line number 100, you have written scanf something. So an interrupt will occur for the keyboard and in return it has to execute a small code. So from line number 100 it will load the address of the interrupt for the keyboard, execute it and return back to 101. So from the main program it goes for executing the interrupt service routine and again returns back. So while coming back, it has to load the previous program counter. So before going, the program counter has to be stored somewhere. Correct? So this is the way the booting takes place. Any doubt for booting? For these two slides, if you have any doubt, you ask me, so that next we will go for the type of operating system. Any doubt on booting process? Okay. That the activities that we are running stored prior to the interrupt service. No, the question is that are the activities that we are running stored prior to the interrupt service? No. See, what we are doing while executing my program, suppose in my program I have a scanf statement or printf statement. You know, in that case, the program requires the hardware. In that case, the program requires, and whenever a hardware is required, so in return to the hardware call, a service routine is executed. So all those so these are already for every interrupt the program is already stored, that is correct, but which one will be executed, it depends on your program that you are writing. So for keyboard the routine is already stored, for printer it is already stored, for monitor it is stored, for software interrupts also it is being stored. Suppose divide by error, divide by zero error, that is what to do, what message should come, that is already stored. If that occurs in your program, then that particular interrupt service routine will be called. Is it understood or any doubt? Is that understood? How will the activities be resumed after interrupt service if they are not stored? See, all these are being, what I said, interrupt service routines are fixed and they are being stored in lower memory area. Interrupt service routines are fixed. How many interrupt services are there? It is being fixed. So now, whenever there is a problem, it goes to the interrupt service routine, execute and return back to the, like a function call you do. In function call, what it does, from main function, it goes to the call function, there it execute and returns back. Here also, it goes to the what interrupt service routine, execute all these tasks and return back. So all these interrupt service routine are fixed. How many interrupt service routine is there in the system? Okay. So now we'll go for the different types of operating systems. Different types of operating systems. Usually we use some of the operating systems like Windows, Linux, these operating systems we are using. And in your lab classes, we will be doing some Linux, or whatever we will do, we will be doing on the Linux operating system. Well, today we have lab class, we will be going on this Linux platform itself. Anyway, so there are different kinds of operating systems are there. Some of you might be knowing, some of you may not have encountered till now. So we'll be discussing those now. What are those different kinds of operating systems are? Slides are not visible. And the slides are not visible. Let me again share it. It should come. I have shared it. Let you please. It is visible. Everyone is saying it is visible. So, okay. So it is visible. Oh. Okay. So now coming to the first category of operating system is the batch processing operating system. Batch processing means, before going through these lines, let me tell you in brief that what actually a batch processing operating system is. The batch processing operating system says that we have memory in which your operating system resides. You load one program into the memory, user memory, right? You know, memory, there are two parts. One part your kernel or operating system resides. Second part is your user memory, user area. In the second part, one program will be loaded, one program only, which will be loaded, and all the tasks which are related to that kind of program will be executed at a once. When that is over, all those are being over, then we go for next batch of job. Assume that we'll take an example. May not be this Word, Excel are there, but I'll give an example. Suppose I load, there are many tasks that is receiving to me. I am a computer operator. Many tasks are coming to me. Word, some are in word processing, some are Excel, PowerPoint, in different order they came. So what I'll do, first I will batch them. All word processing work as a group, all MS Excel work as another batch, all PowerPoint work as another batch. So I will load MS Word, I will do all the tasks which are in MS Word, I will unload it or I will take out, then I will load PowerPoint and I will do all the tasks which are there in the PowerPoint. So at a particular time, how many processes are there in the memory? One process only, either Word or Excel or PowerPoint, and what we will do, we will execute all those tasks which are related to that particular process. But think of, in an online mode or when you are working, you do not know what is the order in which the tasks will come. There might be a chance first Word, then PowerPoint, then again Word will come. No, so this is not practically possible in online manner. If all will submit their task and later I will go for execution, then that is what. So that means it is a offline. Basically, it is a offline task. So computer operator will batch the tasks together, and then it will start executing batch by batch. Correct? So in between mid 50s and 60s, the common input device or card reader and tape drivers. Correct? At that time, people used to read from the card readers. Okay, and the tape drivers are there from which the data has to be read. And the common output device are printer, tape drives, and card punches, where it has to be. These are called the punch cards, where we give the input and out. So users did not interact directly with the system. It gives the work, it will wait till the result will come. So user did not interact directly with the system like we do now. We give input, we get the output, again we give the input. That was not there. So users prepare a job consisting of program, data, and information about the nature of the job. Then these jobs are usually in form of punch card submitted in the computer operator. So it is in form of punch card. Punch card is a kind of rectangular card. In one corner is a slight cut. There are around 79 number of rows and 79 of columns, 79 number of columns with 25 number of rows. Anyway, in those punch cards are being given to the computer. The output of these jobs appear after some minutes, hours, or days, right? So we give it, we run the program, it will take, if we have a lot of tasks to be done, it may take minutes, hours, even some days. To speed up the processing, jobs with similar needs are batched together and run as a group. This is important. Just look over here. To speed up the processing, what they do? The jobs with similar needs are batched together. So similar kinds of jobs are batched together and they run as a group. So every time I don't have to load and take out and load another program. It's not like that. I load MS Word, I'll do all my tasks. I'll take out, then load the next one. So jobs with similar needs are batched together and run as a group. The batch of jobs were submitted to the computer, and after completion of job, the output were printed using a line printer. When it is being given to the computer all at a time, and once it is over, this printing is through the line printer. But we cannot interact in between. There is a lack of interaction between the user and the job while the job is processing. Because I said what? I'll give the input, I'll wait till the output will come in the printer. I cannot go interacting in between. I cannot give any instruction over there. I cannot input my values over there. Right? So this is basically the offline processing work. This is usually offline and interaction is not there. So what is the advantages and disadvantages that we get? What is the advantages and disadvantages we get? See over here. Batch processing takes much of the work of the operator to the computer, because most of the task is done by the all input, whatever we want, that has to be given. Increased performance as a new job gets started as soon as the previous job is finished without any manual intervention. So one job is finished, automatically it takes the next job because it's being batched and given in a sequence. Correct? But what is the problem over here? Problem, what I said, one basic problem is that CPU is often idle because the speed of mechanical IO devices are slower than the electronic devices. The processor works very fast as compared to the IO devices. And it has to depend on IO devices because the output is written on these line printers. The input has to be read from the punch cards. That takes a lot of time, and processor is idle only in that time. So reading of data by card reader takes more time than processing by the CPU. The CPU is idle at those times. And the turnaround time can be very large. What is turnaround time? The entire time, starting from your submission of the job till the completion of the job. You submitted at a particular time and job is completed at another. I submit at 9:15, job completed at 10:15. So turnaround time is 10:15 minus 9:15. This turnaround time is very large, and it's difficult to debug the program because one program is followed by the next one like that. So to find the error, find and correcting errors is difficult. Job could enter to an infinite loop due to the lack of protection scheme. One bad job can affect pending jobs. Correct? So, and another thing is that this lot of all these jobs may be writing into the printer, right? So, how to write all this to the printer at a time? To overcome this problem, a concept is used called spooling. Spooling is also important. Spooling usually comes as a note, short note. What is this spooling is? Just see over here. The spooling says, spooling stands for, spooling is usually used in batch processing systems. It's a simultaneous peripheral operations online. The full form for the spooling is simultaneous peripheral operations online. How will you do it? What it does, spooling refers to putting data of various IO jobs in a buffer. So what we have, this is the card reader from which it takes input, and this is the output where the printer will get the output over here. This is the memory, means primary memory, temporary nature, and here we have a disk, the secondary device. So the spooling refers to putting data of various IO jobs, input output jobs, in a buffer. Buffer is what? Buffer is a small area in memory. A small area in memory, either in memory or hard disk, which is accessible by IO devices. IO devices can access this buffer. So in spite of reading the data from the card and storing it in memory, and then processing, the cards are read directly to the disk. So what we do actually, we read the data from the card, store it in the memory or disk actually, that we do. Here it doesn't do that. It says that the cards are read directly to the disk. The location of card images stored in the table kept by the operating system. Where it is being stored, those addresses are being kept in the operating system. So the processor will go on doing the task. The output of those are being stored in the disk, which has to be written. The addresses are kept by the operating system. So at the time of processing, CPU gets the input from the disk. To print certain output, the line is copied into the system buffer and is written to the disk. When the job is completed, the output is actually printed. So actually your output, it doesn't need that all your one program's output will be printed, then it will go for printing the next output. It says that all your output will be stored in the buffer itself, in the disk itself. Now also in our computer a printer, if you have ever marked, suppose I give print of 100 pages. So you give print and print all, suppose 100 pages are there. Once you give it and close and start doing another task, there will be no problem because those are being transferred to a temporary buffer area, printer buffer area, from which it will be given to the printer for printing. So processor will not be engaged in checking that where the data is there. Your data is now transferred to a temporary area, memory. Here it says, similarly, instead of reading every time card to the memory or disk, all those are stored in the disk and from which it can be read, and the starting addresses are only stored in the operating system, so that it can be get printed over there. So what is the advantages that we get from here? The spooling operation uses a disk as a very large buffer. Like the buffer that you say, here disk is a buffer, you can think of this disk is a buffer. Spooling is capable of overlapping IO operation of one job with processor operation for another job. While you are printing by taking data from the disk, at the same time processor may be busy with doing some other task. So processor is not engaged, always processor is not engaged in printing itself. Whatever data to be printed, it is there on the disk, that will be read and get into the printer. So processor will not be engaged. So processor at that time may be engaged in doing some other task. Is it understood, the batch processing system? Or anyone having doubt on batch processing system? One task at a time will be done. One task at a time. However, the jobs of similar needs, the jobs of similar needs are batched together. Correct? So by using the spooling, we can increase the performance so that all our output data to be written, IO data can be put on a disk. So that the reading and writing from the disk to the IO device and the processor processing can be done simultaneously. Is that clear? Okay. The second kind of operating system is called the multi-programming operating system. The second kind of operating system is called multi-programming operating system. So look here, look into this diagram. In this diagram, first part is your operating system. Sometimes it is being over here or sometimes over here at the last one side actually. Usually it is in the lower, we say at the low memory area. The operating system or kernel is being present. All these area are called the user area. In user area, in batch processing operating system, we usually keep one job at a time. Here, in multi-programming operating system, multiple jobs can be kept. Multiple jobs can be kept in the memory, like the Windows that you are using. In Windows, we can have word processor, Excel, you can listen a song and get printed a document on the printer. All this job can be done at the same time. So multiple jobs will be reside over here. In a multi-programming means more than one program can reside in this memory. So sharing the processor when two or more programs reside in the memory at the same time is referred to as multi-programming. But let me tell you clearly that multi-programming never write that multiple programs execute simultaneously. No, they are not executing simultaneously. If you have one CPU, can do one task at a time. One CPU can do one task at a time. If you have two CPUs, that can do two programs. This is correct. But multi-programming says even if you have one CPU, but multi-programming says more than one program will reside at the same time in the memory. Now we'll say that what is the advantages if multiple programs will be there, but processor is doing one task at a time. So what is the advantages? See, it says that even if you have multiple programs, even if you have one processor, the processor is taking data from the memory itself. So program is read from disk to memory, and from memory it is getting executed. So every time if you have multiple programs are there in the memory, it will be easier for the processor to switch between these programs. And the switching between these programs is very fast, so the user could not get that it is actually multiple programs are executing. While you are working with a MS Word, can you listen a song or not? But if you have one processor, how do you think that both work is doing at the same time? It is not exactly same time. The switching between the switching of this control is done so fast that user could not able to differentiate between them. I'll give an example of the problem that you face in a day-to-day life. Most of you, I do not know how many might be using that when you go outside for taking some golgappa or gupchup kind of thing. Have you ever marked how that person serves you? When you go to for having gupchup from your street, although you might not be going in these pandemics, but usually people when go to market for having the gupchup or golgappa, what the person does, whenever you reach there, it will hold you one leaf container where you have to take that. So once he holds you, that leave, that means now you are online, that you are now active. It is not that it is giving that leave to 100 people, it is giving to 5 or 10 people to whom he can serve. Have you ever met, is he serving those things in both the hands? He is serving in one hand only, because it's a one processor, he is serving one at a time. He is serving one at a time. It is not that in left and right hand two people are being served. He is serving one at a time, but five people are in line, or six people are in line. Those people are in line, those are active, those are the programs which are in memory. And it has a limit. It is not that any person will come and it will give you that leave. It will make the other people's wait over there. But he is serving all these 6 peoples one at a time, but these are all active. So similarly, in our operating system, multiple jobs will be there in the memory, active all the time, and processor will switch between them. It will serve one at a time, but it will be very fast. Till the time you have finished, you have consumed your book job. At the same time, he might have served somebody else and put quickly, he would have written. Right? And processor does it very fast. So multi-programming assumes a single shared processor. Single and shared, that means one processor which is being shared by multiple number of jobs or programs. So multi-programming increases CPU utilization by organizing jobs so that the CPU always has one to execute. So CPU utilization will be increased or not as compared to your other batch processing operating system or serial processing operating system. Serial processing I have not written over here. Serial processing means doing one task at a time. Doing one job at a time is serial processing. So I have not included in the slide itself. So this multi-programming, is it does it have, okay, one query over there. Does it mean that the processor switches between different, yes. The processor switches between different programs. Very quickly it switches between the different programs. How it switches? Because your program, every instruction is either a input output instruction or a CPU operation instructions. While it is busy in doing some IO operation, it switches to some other operation where the CPU is required. While the CPU is executing, that time IO may be done at the same time. So switching and all this is being done very frequently, correct? So you have a single shared processor. So multi-programming increases CPU utilization by organizing jobs so that the CPU always has one to execute. This is important, one to execute. CPU uses one, we execute one at a time, but multiple programs will be there in the memory. An operating system does the following activities related to multi-programming. An operating system does the following activities related to multi-programming. What is that? The operating system keeps several jobs in memory at a time. Operating system keeps several jobs in memory at a time. Where it keeps? In the memory, not on the disk. Memory means primary memory. A set of jobs is a subset of the jobs keeps in the job pool. Set of jobs is a means what? There might be a very large number of tasks. A set of jobs may be brought to the to the memory. Operating system picks and begins to execute one of the job in the memory. There are maybe I am executing Winamp, I am executing MS Word, I am using PowerPoint. You may have Word, Excel, both Word and PowerPoint. Maybe both are there in the on your desktop. But when you click on the MS Word, now MS Word is active and you are doing over there. The moment you click on the PowerPoint, now the processor is getting instruction from the PowerPoint itself. So multiple programs may be there, but processor is executing one at a time. At the same time, you might be listening the song. So multi-programming operating systems monitor the state of all active programs and system resources using memory management programs to ensure that CPU is never idle. To ensure that the CPU is never idle unless there are no jobs to process. Correct? Multi-programming operator monitor the state of all active programs, whatever being active. System resources using memory management programs to ensure that CPU, so it will have maximum utilization of the CPU, right? Unless there is no jobs to process. Okay. One more thing to say that the previous scheduled meeting for today, I am just deleting it. I will reschedule it because this is the incorrect information is there. I will delete it and oh, it is only deleted for me. Okay, so I'll post it again. Okay. Now, what is the advantages and disadvantages of this multi-programming operating system? Advantages is that it has high and efficient CPU utilization. So we have maximum utilization of the CPU because multiple programs are there. CPU busy in doing, serving all these programs. User feels that many programs are allotted CPU almost simultaneously. So all programs will think that CPU is only allotted to it, but actually CPU is allotted to multiple programs. So every user will think that CPU is allotted to me only. So all programs will run in an isolated manner. But what is the problem? Problem is CPU scheduling is required. So we must know that what is the order they have to be served. It is not that always first, second, the way the Golgappa wala is serving. It is not that 1, 2, 3, 4 again 1, 2, 3, 4. It's not like that. There are different scheduling algorithms are used, right? Like if you go for printing some papers, or you might want to go for some make some photocopy of these some papers to a Xerox shop. What it does? Usually he takes what? First come first serve. There might be a chance if he is printing a book and somebody will come that I have to print only 2 pages. Then he gives emphasis to that person who is having 2 pages, because if he will serve only 2 pages, then he can be served and he will go happily. Rather than waiting over here to thousands of the pages to be printed by the previous person. So we require different kind of scheduling. So some of the process might be requiring very few attention of the CPU, and some might be requiring very large amount of time. So it has to be, the processes has to be scheduled accordingly. To schedule that, we have to design the operating system in that way, so that complexity increases, right? To accommodate many jobs in the memory management is also required. Memory management is also required because multiple jobs are there in the memory, and that creates a problem. Some program may write into another program's memory. Okay, there is a query. Will any inconsistency rise while switching between the programs? No. Usually the operating system is written in such a way that inconsistency doesn't arise. But we cannot give a guarantee that 100% it is being resolved. Still, taking all the cares, there are some situations the system hurts, your blue screen. Have you ever marked that sometimes blue screen appears? Whether you marked or not, I don't know. In some cases, you will see that this blue screen will occur. That means there is a problem in the memory management. Yes. If you have seen, then that's actually because of the memory violence. There is a memory violence when some processes are writing into some other processes memory area. Suppose Word, Excel, PowerPoint is running at the same time. All are there active. So all instructions to MS Word should go to the memory which is allotted for MS Word. All instructions that I am giving for PowerPoint must go to that particular location. If it violates or some address computation, there is some error, it will write into some other program area, then that creates a hazard. Actually, there is a problem, right? So operating system should be so designed or should take care of all these. So designing of operating system to handle these things, those complexities increases, right? So the operating system that you are using, the Windows or the operating system which are multi-programming operating systems, Their designing operating system is not that easy, right? Okay, so Swapnil, there is this. If there is some bugs in one program, then what will happen? Will all the programs will be aborted, or only the single program will be aborted? Yes, very good question. See, I have 5 programs are there. For 5 programs, all 5 programs are stored in different memory area. So if I have program in one memory area, then it will only halt that one only, that program only. But what happens sometimes, suppose there is some memory area which the program has been allocated may not be belongs to that particular area which is being shared. In that case, the entire system has to be aborted or halted. For example, I have many programs I have opened at the same time. 20 different programs I have opened. Once the degree of multi-programming increases or more programs will be there, the system may go to, sometimes it will halt. At that time, you have to abort the systems or abort the programs one at a time. Correct? So what you have, if you have multiple programs are there, if you have bug in one program, so that particular program can be closed. But sometimes if they share a common memory or common data, that time the program, it may lead to the entire system to be halt. But in most of the time, it is program specific to that program only. Is it understood, or anybody having doubt for multi-programming? Is that clear? Okay, today is time now. I have to take the attendance and then I will ask you for if you have any doubt. Roll number 1, 2 is absent. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 30, 37, 39, 48, 73, okay. Again, I am calling the absentee roll numbers. If it is present, please. One also present. Achha, okay. Roll number 2, roll number 16. 16 is present. Now, 22, 22 absent. 25, 25, no. 27, 30, 37, 39, 48, 48 is present now. Okay. 73, no. Okay. If you have any doubt, you ask me. Roll number 1 is present, I have written. 16 is present, I have written. Okay. So if otherwise we will close it and then lab will again meet, right? Okay, thank you all.